quadratic functions and their graphs. This slide is loaded up with a lot of information.
Chock full of goodies.
The first thing you need to know is a quadratic function is a polynomial function of degree 2. Its graph is a parabola. The standard form for a quadratic function is given up there. F of x equals ax squared plus bx plus c. That should look familiar because that's what we use when we're doing like the quadratic formula and stuff like that. Vertex formula. Either the lowest point or the highest point of your parabola, that's the vertex, depending on if it opens up or opens down. If it opens up, it's the lowest point. If it opens down, it's the highest point.
Yep.
And so the way you can find that from standard form is this little formula we've got, negative b over 2a. You find that, and then you plug it into your function, and that gives you f of negative b over 2a. Or sometimes they give it to us in vertex form, which looks a little different. It's down there, right there.
And anytime you can work straight out of vertex form, that's always easiest with parabolas.
Yeah.
Like every time.
Don't like try to FOIL it out and multiply and stuff, because it actually is easier. Because the vertex of that form is h comma k. Like whatever's inside, you do the opposite of. Whatever's outside, you leave alone. Just like when we talked about transformations and
Yes. The super secret opposite society is in
super secret opposite society.
bloom inside parentheses.
Yes.
Anytime you're inside parentheses.
Anytime you're in parentheses, you change the sign. So that negative h, it becomes positive h for our vertex, and the k on the outside continues to be positive k.
That's correct.
The axis of symmetry, depending on which way you found your vertex, it's the x value. X equals whatever. It'll either be negative b over 2a if you found the vertex that way, or it'll be h if it's already in vertex form, right? It'll be x equals h if it's in vertex form.
So Jaggery, people get copy. You gotta use copy. Has a lot of storage space in copy that they'll give you.
What? I haven't used it yet.
Links.
Yeah, I got your link. I haven't started it yet, but I think this is another place to save stuff.
Just by getting like if you invite people and stuff like that, I'm up to 22 gigs that they've just given me.
That's awesome.
That's pretty good.
Like there's one they'll give you 5 gigs if you share on Twitter that
Yeah.
you've used it and stuff like that. They just give it to you.
Nice.
So
That's really nice.
and it integrates with your computer, so you can save here, save there.
So between Drive, Dropbox, and that,
We'll have like a million gigabytes.
I've got them all on my phone.
and
Yeah.
it's
I'm
only
the same
3
way.
places, so it's
Yeah.
not like you're digging all over the
Yeah,
place for
you just
stuff.
have to remember which place you saved what.
Well, and on my phone, I have it automatic. Like when I take pictures, it automatically saves to copy.
Mhm.
So it's just like it's your backup.
Just right
Yeah.
there.
So
Neato.
Sounds good.
have a good one.
Okay,
Yeah.
thanks. Little editing job.
A little bit.
It's heading our way.
So
Okay.
should we have a momentary like blank?
Yeah.
Like if we wave or something, like we need to let ourselves know that this is where it's going to start.
I'm gonna point to the camera and
And then we're
mentally
gonna
we're gonna
start?
count to 3.
Okay.
And then we'll be able to start.
Okay.
All right.
So I don't know where we left off.
Well, we were talking about the axis of
The
symmetry.
axis of symmetry. If it's in vertex form, the axis of symmetry is x equals h.
And if,
Are you gonna write that?
yeah, sorry.
So it depends on how you found your vertex as to which of those two things you would use. So why don't we draw a parabola and just point out like
I know what
we're
this looks
talking
like.
about. X-
No mocking my skills.
Y equals x squared. Well, the scale there is a little tricky. Tried to
I'm
trip you
paying
up.
attention. I'm paying attention. Oh wow, this is way up. I'm just gonna go with right here.
That kind of looks like a V.
Yeah, I'm gonna curve it at the bottom. It'll be, it's gonna work. It's gonna work really bad. No mocking, Mrs. Stevenson.
We
my
all know that
artwork.
this is a parabola, so it'll be okay. So this y equals x squared is what he's graphing right now. If there is a positive in front of your x squared, it is a parabola that opens up, which means that the very bottom point is your vertex. And so since we didn't have anything being added to either our x in parentheses or outside of parentheses, our vertex form, it's kind of in vertex form because our vertex is at 0, 0.
Yep, x plus 0 is x.
Yeah, and so then we could talk about the axis of symmetry being the line x equals 0. The line that is vertical that goes through 0. And what we mean by axis of symmetry is that's where if you fold it, hot dog style, it looks the same on either side.
Mirror image, except for this one, which of course is not perfect. We've all had a chuckle. Let's move on.
Okay. If we were to graph y equals negative x squared, what changes?
I'm just going to freehand this one because it'll be better.
That is so much better freehanded. That's amazing. Where was that before?
You know, I was saving it up for later.
The negative, if we remember back to our transformation rules, it's not inside the parentheses, and so this is a reflection over the x-axis. And so that just means if you see a negative in front of the x squared, that means that it is a parabola pointing down. And so our axis of symmetry, since we didn't move left or right, is still at x equals 0?
Yep.
Yep. What about that crazy thing down there?
Well,
y equals 2 times x minus 2 squared plus 1.
The super secret opposite society is now kicking in, so that means my vertex is going to slide to the right 2 times. So
Yes.
he is now going to, let me get a little bit of a color difference here.
Okay.
And so here's my new vertex.
What about up 1?
Well, and then I hadn't got there yet.
Oh,
so
okay.
I slide to the left, slide to the right 2
Slide
times,
to the
and
right
then pass the
twice.
duchy up once.
What did you just say?
You know that one song? Pass the duchy to the left one time.
And then vertically stretch by 2.
So instead of coming over here to my, to 3 and going up to 9, I'm going to go up to that times 2.
Right.
Yeah. So
It times your
it times
your y values by 2.
So I can't even put that on this graph.
Okay.
But it's really thin. I'm going to freehand this again. This is going to be totally great.
So
Actually, let's see.
While he's freehanding this,
0.
the important thing is that our vertex was at 2, 1, so that's now our bottommost point. If we were comparing this to the graph of like y equals x squared, we know that it's thinner because we're vertically stretching by 2. All of our y values end up being doubled, and if you're trying to make this accurate, like vertically stretch it first and then move it is the easiest way to do it, in my opinion. I'm not even paying attention to what you're doing. And since it's a positive 2 in front, remember that means it opens up. If it had been a negative 2 in front, it would open down.
I feel like I grabbed something wrong here. 0 minus 2 squared is 4 times 2 is 8
That's
plus
a
1
terrible
is 9.
9.
Okay, so it's 0, 9. And by axis of symmetry, if I'm at 0, 9, guess what? Over here at 4, I'm at 9. And so here is my graph. Almost. Yet again. I gotta quit putting points down.
Since our vertex was 2, 1, our axis of symmetry would be the line x equals 2, because the axis of symmetry just takes your x value from your vertex right there at x equals 2. So there's our quadratic functions.